Okay, we're looking at exercise set 1.2.3, number 2. It states police car is traveling at he's traveling 5 kilometers behind you, and you're moving along at a rate of 120 kilometers per hour, and the police car is trying to catch you traveling at 180 kilometers per hour. So this is a relative velocity question, in which we have both objects moving in the same direction. So we will set up part A, which says how long will it take the police car to actually catch you. So we're looking for a period of time here. So if we take a look at part A, we're really figuring out time, right? Let's change up the color of my pen here. I don't like that color. Okay. So let's look at part A. So first thing we always do is write down all the factors or all the variables that we've been given so far. So we've got a distance to make up here, right? We've got a velocity of your car, and we've got a velocity of the police car. Okay. So first of all, let's make our positive direction moving to the right. This is for when we start up here. So let's look at what we got. We got a velocity of the car, which is equal to 120. So 120 decimal kilometers per hour. And we get the velocity of the police car, the PC. Pen's acting up, which equals 180. I guess I said to write slower. Kilometers per hour. We also know that we have a distance to gain here, so this is the change in displacement here. This is messy. Of 5 kilometers. Also, we need to make up 5 point. Hang on. Let's clean that up. 5.00 kilometers. So the first thing we do is figure out the relative velocity here. It might look fairly simple, but we'll do the math anyway. We know that the velocity, so the kind of the relative velocity, we'll call this, I'm just going to call this velocity total. In this case, is the velocity of the police car, PC, minus, always, right, the velocity of the other vehicle, which in this case is just what is called the car, BC. These are both moving to the right, let's assume, chasing each other that way, so everything's positive. So velocity total is equal to velocity of the police car, which is 180. Pen man, okay, 180 decimal kilometers per hour minus 120 kilometers per hour. So our velocity total, or in other words, the relative velocity of this situation is 60 kilometers per hour. So what this tells us is that the police car is gaining on us at a rate of 60 kilometers per hour. Let's slide this thing over a bit. See if I can make this work. Whoop, not that. I'm rusty. I think it's this. Yeah, so we're going to Yeah, let's just slide to the right a little bit. So we're working with 60 kilometers per hour. So let's write that back over here, since we've lost it off our page. Whoops. V total is 60 decimal kilometers per hour. Okay, so we know that the distance that needs to be covered is 5 kilometers, so there's our D. So that's the D total. Is 5.00 kilometers. So we can now find the time total, because we can use our V as d over t equation. So t total equals, that's what we want to know, right? How long will it take? So we know that V is d over t. And in this case, this is V total, D total, over T total. We know V is 60 kilometers per hour. That's equal to 5.00 kilometers over T total. So we're going to do a little algebra here and multiply both sides by T total. So instead I get 60 kilometers per hour times T total is equal to, these guys cancel here, 5 kilometers. Alright, to get T total, we're going to divide both sides by our 60 kilometers per hour. Okay, I need to move up a little bit. Okay, that's too far because it messes with my pen for some reason. Okay, T total is 5 divided by 60, 0.038 hours. Okay. So it'll take 0.038 hours. And if you want to change that to minutes, you can multiply that by 60 minutes in an hour. So we could convert this to minutes, and it makes a little more sense. I have to check that on my calculator myself. Let's say 0.038 times 60 minutes in every hour. I get 2.28 minutes, so almost 2 1/3 minutes. 2.28 minutes. So we could say, therefore, it will take 2.28 minutes for the police car to catch up. And that's the end of part A. Okay, I'm going to try and move all this out of the way here, and we'll look at part B. So let's take this stuff and move it. Let's change color. Okay, and let's look at part B. And B says, how far will the police car travel to catch you? So while they're catching up this 5 kilometers, both cars are still moving down the highway at a pretty quick rate. So we need to figure out how much ground they cover just to make up that 5 kilometers. So again, let's look at, this time we're just looking at the police car. So let's see, what did we have? Remember, we had the velocity of the police car. It was 180 kilometers per hour. Let's say going that way. Oh, there's a decimal in there. Sig figs. Okay. We now know that the time that he will travel from part A is 0.083 hours, or that 2.28 minutes. Though we're working in kilometers per hour, so we'll keep it in hours. We can look at this V equals D over T equation one more time. Holy moly. V equals D over T. And this time we're worried about the police car. Time of the police car. And this was also time for the police car. So during that time, let's see, he was doing 180 kilometers per hour. We don't know the total displacement of the police car. Okay, but we do know for how long. 0.083 hours. So let's see, multiply both sides by 0.083 hours. So I get 180 kilometers per hour times 0.83. Whoop, 0.083. Hours is equal to, now these cancel on this side, so I get DPC, which is displacement of the police car, which is what we want. So let's try and move everything up here if we can. Whoops. Oops. Okay. 80 times 0.083 comes out to 15. So 15. See, these hours cancel. So top and bottom. I'm up with kilometers, which is good. We're looking for measurement distance equals displacement of police car. So it took them 15 kilometers to make up that 5 kilometer gap between him and you. Final answer, therefore, the police car will travel 15 kilometers to make up the 5 kilometer gap. And we are finished this question.